Hello everybody, we're back with minimum window substring part 2. Here we will be doing a O of M solution for a min window. Earlier we did a M times M solution, or I think it was the number of items inside our hash, and that takes a lot of time. So what we're gonna do this time is do a missing item. So this time, by looking at only the missing items and by reducing it to a point where we can know that something's in the window or not to O of 1, we can reduce the cost and bring ourselves down to O of M. So let me show you what I mean. So if you haven't seen the first part, you probably might want to check that out, see what the background about this problem is. But essentially, we're trying to find this substring in this substring here, and the output is B, A, and C, because we found it, and this is the shortest window. So this is a sliding window problem. The reason why we're doing a second part is because the hash map that we chose to do in part 1 cost us O of the size of the hash map time, which is going to be the size of M. So it could be the size of M, so it's going to be M times M. So that is a very large size that we don't want to mess with. And so here we come in with a second solution where we're going to reduce that cost to O of 1. So how we're going to do that? So the plan is, what we have is an I and a J, right? And we're going to create a dictionary of items. So everything starts with 1. And we're going to create a missing variable. So we're missing 3 items right now, okay? And let's create our start and end. We're starting at 0 and ending at 0. So our plan is to create a I and J pointer to signify this current start and end, get a minimum window for start and end, create a missing items that decrease when an item becomes positive, is positive, and decrease it until it is negative. So we're using both parts of the number spectrum, both the positive and the negative numbers, to do this problem, to give us this, make this possible for us. So let's check out our first item. So we look at A, and what we see is that if we look at A and we remove it from our items, we reduce our missing by 1. Then we see our next item, D, so we add that, but we don't remove it from our missing because this is a negative number already, right? And so nothing changes. So with that, we move to O, and O is now negative. With that, we look at B, that is another 0, that was positive, and so our missing is now minus 1. With that, we look at CE, and we add another one to our dictionary of negative 1s. So because we added our items from T earlier, those are the only items that can become positive. So here's the reason why. Because those are extra numbers. When we look over other numbers and we add them back with the I later, the maximum they can reach is 0. Okay, let me just show you as we go through all of this code. So we have this 0 here, and here we're finally not missing any items. So if no items are missing, then we can shrink the window. So we can start shrinking the window now. So bring I plus equals 1. So, and we can start shrinking the window until the window size, until we are missing items. So let's shrink the window now that we're not missing anything. Let's increase the window. Oh, by the way, if there's no item missing, also then we can update our start and end. We should do the +1 after we check. Yeah, that's kind of important. So here we are. We increased the I, and our A is now missing. So we're missing one item after our first move. Of course, our start and end has been updated before this. So our start and end is now at J plus 1, which is 0, 1, 2, 3, 4, 5, 6, and at 0. So our missing is now 1. And this means that we have A, D, O, B, E, and C as our answer right now. As we move I up, we lose the missing, and so we're going to keep moving our items up. So we have an O, so that's -2, and we have D, so -2, and E, we have -2, and we have B, which is going to be our, we're going to get another 1, so it's going to be -1. And then we have an A. So finally, we're going to bring that down to 0, and everything that we're no longer missing anything. So now it is going to be 0. With that, we are able to start closing the window now. And if this window was smaller than this window here, we would change it. But it isn't. If J minus I is lesser than end minus start. So with that, we are able to start closing this window. We close the O, as you can see, this is going to be -1. We close the B, as you can see, this is going to be 0. We're still not missing anything yet. And we have E. E is going to be -1. And C is going to be, we're going to close that window there. As you can see, this is about the same size as before. So I don't think that anything changes. So we're going to just increase I. Now, I is now here. We do that +1 after we close that window. And lastly, we have I and J. So we need to keep moving J up until we get C again. We bring that down to 0, and missing a 0. Of course, we have N equals -1. That's all fine and dandy, because that will never cross that become a positive item. And so now we're not missing any items anymore. We can start shrinking our window, and we shrink our window again. As you can see, this D is our last D, so it becomes 0. That doesn't change anything for us. And now we have an E. We lose the E, that becomes 0. And O becomes 0 as well. And we have just the B, A, and C. So that window is actually smaller than our current window, so we just set our I to be at B. Whatever that is, let's say 9, and let's say this is the end is going to be like 13 or something, right? and we get our final item, which is B, A, and C. So that's how we're going to do this problem, and let's implement it. Here we go. So we have I and j to signify the start and end. So I equals j equals 0. And start and equals end is also equal to 0, which is equal to I and j. Everything's equal to one another. So we start everything off in the same spot. So what else are we going to do? Create a window, get minimum window for start and end. Create a missing item. Okay, so we have to create missing items. So missing is equal to length of t, and our hash is going to be what we need, which is equal to a counter of t. With that, we can do a for loop to get our items. So for j in enumerate s starting at 1. The reason why we start at 1 is we have to get that range of j plus 1 when we do it s, I, and j. As you can see, we have to do a plus 1, and there's a lot to do later. We have a j item, and we have our I item. Let's start it back here. We're gonna just redo our code from the beginning. So now what we need to do first is to make sure that no items are missing so that we can start shrinking the window. So if we are missing, which we are going to check if s of j is in our window. Let me think about this for a little bit. I don't think these instructions are very clear. I don't know how to implement this. So we need to create a missing item that decreases when item is positive and decrease it until it is negative. So we need to do need of s of I is greater than 0. Missing is minus equals 1. And that means, of course, need at s of j is minus equals 1. So only when it's greater than 0, we're going to do a negative 1, and we're going to decrease this item every single time. So once we are no longer, if we have no items missing, if not missing, then while I is less than j, and we're going to, and what else? We need to make sure that we're not missing, that we will keep increasing our I. So I plus equals 1. While we're increasing, we want to make sure that we want to take care of checking if there's no items missing. So I mean, take care of bringing down our j. So if j minus I is less than end minus start, then that means that we need to set our I and j equals to start and end equals to I and j. So start, end equals I and j. let's see if we finish off these instructions. I don't think we have, because now we still need to remove the item from our missing. So missing s of I plus equals 1. And if missing or need, if need of s of I is greater than 0, then missing plus equals 1. So I think that takes care of most of this. And we have s of I plus equals 1. And we move the I. We make sure everything's in. Yeah. I guess we can make sure this is happening first and then move this down. I think this makes a little bit more sense to me. Because we make sure that we do a check first, and then we start increasing the I to make sure that we're not missing anything. And once we are missing something, we will stop increasing I. And J keeps increasing. I think this takes care of most things, and we just need to return start and end. I don't know if this will work, but let's run the code. I'm sure something's messed up somewhere. And I'll do a pause, and I will take a look at what's going on. Oh, right. This is going to be enumerate our character. So of course this is going to be much easier if we just did this instead. So run code. Okay, we have an empty item, so we have an issue. I'm gonna go take a look at this and give me a pause. Okay, so we found what was missing here, and that was the end is equal to 0, because the first time that we check this, 0 minus 0 is 0, as you can see here. And if this is the first time that we found it, we have to set it to 0. And as you can see, it is successful to run. So yeah, do we actually need this line? I don't think so. So let's remove it and just move this down this way and run the code again. Make sure it works. I don't know why we need that line of code. And yeah, that's great. We have made this code much faster this time around. We were able to code this up pretty quickly using the negative space that we thought about. Actually, we didn't need to enumerate this. Well, actually, enumerating does work better. So with that, we were able to get a new start and end, and then update our s of I every single time to make sure that we were able to get our new minimum window. Give me a pause and maybe it will make this even better. But now that after you do an evaluation, I would give me a little pause, and then maybe I can make this even better. So it's O of n, m time for length of s, and we also ran we also used up O of m for length of s. That's how big our hash map is going to get. So it's O of m and O of m, or O of m time. an O of M space, depending on how many different types of characters we get. Give me a pause. Okay, I think this code looks pretty good to me. If you have any better code, please put it in the comments below. Let's learn together. And if you enjoyed this video, like and subscribe. Want more videos like this, check the link in the description below. Thank you very much, and I'll see you in the next one.